In this session, I'm going to teach you on K-nearest neighbors machine learning model. It is a supervised machine learning model used for classification as well as regression. So more commonly, we use it for classification problem. So if you want to import machine K-nearest neighbors for classifier from so we have to import using neighbors, that is from sklearn.neighbors import a neighbor classifier or neighbors regressor. So the library that you used here is k from sklearn.neighbors. You can import k neighbors classifier or k neighbors regressors depending on the kind of data set that you are dealing with. If you are dealing with the output class data set where there is a regression problem is required, then you can go with k neighbors regressor. If you want k neighbors classifier, then you can go with k neighbors classifier if it is like a classification kind of data set. Okay. So what are the steps for KNN model? So before going to that, let me show you my class notes. So in K-nearest neighbors, we have seen that it's a supervised machine learning model, supervised algorithm, and it's used for classification problems mostly. But it can be used for regressive problems as well. So let's say you're standing at this point and you are trying to find the 25 houses that are nearest to you. Okay. So you'll calculate distance of the 25 nearest houses. Okay. So then what you have to do is that then your algorithm say wants you to find the five nearest houses in the ascending order. Okay. So what you will do? So you will see the distance and you will take out the five nearest houses. Okay. So then this is all about it. Okay. So let's say these three houses belongs to class A and this two belongs to class B. Okay. So the output class that you are trying to find of this point that is yours is based on these class, the majority class. So in our case, these three classes, whichever it belongs to, that will be our output class because it's a majority we will take. Okay. This is how the outputs class will be if, found out. So an unknown point is here, and you have other data points here. So you'll try to find the distance between the unknown from unknown point and the data points, and you will find the five nearest distance in an ascending order. And whichever class is having highest majority, your output class is considered to be that class. Okay. So what is the aim? Okay. So identifies the data points that are separated into different categories. Okay. So here you see you have a area over here. So we have triangle, a star, circle, and rectangle or square. You can say anything. Let's say square. Okay. So first it identifies the data points that are separated into different categories. So the different categories here are star, triangle, circle, and square. Okay. So aim is it identifies the data points into separate different categories and it tries to classify the new sample from the set. So let's say you have a point over here and you have to classify this one as rectangle, sorry, square, triangle, circle, or star. So your unknown point is here. So what you will do? You will try to find the nearest distance. So we will take five nearest distance. Okay. So five nearest distance to this unknown point is 1, 2, 3, 4. So we have four triangles. So triangles is equal to 4. And the fifth nearest point for this unknown quantity is the star. Okay. The star is 1. So your output class will be triangle or star. It is dependent on the number of classes that are present, majority classes, output class that has having. Okay. So we see the output class will be triangle because there are four triangles are there around the unknown point. Okay, this is like trying to remember the data points, distance, and their classes, and based on how many of those classes are present, and majority of the classes. So majority of the classes will be taken as your unknown point class. Okay. So next, now let's say you want your k value to be 5. So we have already taken k value to be 5. Let's say k value 7. So what we will do, k 7 distance, 7 nearest distance we will check for in an ascending order. So 7 nearest distance, this unknown point is 1, 2, 3, 4. This one is 5. This one is 6. This one is okay. So we have four triangles, one star, one circle, and one square. So what is the output class for this unknown quantity? Still triangle, because the majority of class is 4, right? For triangle. So then also we know that it is triangle again. So how we are going to do? The steps you have to follow. Okay. First, calculate the distance between the unknown quantity and the each our classes. Okay. So we have found out the distance between unknown quantity and each classes. The distance d1, d2, d3, d4, d5. Then sort them in ascending order from smallest distance to largest distance. Then you have to decide the value of k. So then first k distances will be considered for our evaluation, and classes of first k neighbor. So first k distances we have used. So then we can see that classes of first k neighbor we will take. Okay, what is the classes of this neighbor, this neighbor, this neighbor, and then based on the majority class, we'll pick the class of the unknown quantity. Okay, that is the class of the new point. Before moving further, so let me say steps for k nearest neighbor model. For first, decide the value of k. Okay, you have to decide the value of k. How many? What is the k value you want? So that uh, then you can calculate the distance of all data points from unknown point. So first, say tell the k value. So first decide the k value, and then calculate the distance of all the points from the unknown point. Sort the values, sort the values in the ascending order, and then get the top k rows. Here we are taking k value as 5. So top k rows is k5. Okay, top 5 rows we will take, and then identify their respective classes. So after identifying, we know that we have considered that these three belongs to one class and these two belongs to class B. So then, and find the most frequently occurred class amount of those k points. Okay, so most occurred k class will be, let's take this example in 5 nearest neighbors. So 5 points are the most occurred classes is triangle. So 4 times it has occurred. That becomes the predicted class of the unknown point. So our unknown quantity will be a triangle because the majority of the class is triangle across or around the unknown point when we have considered k value to be 5. So now what happens is that becomes the predicted class of unknown point. How to select optimal value of k? So how can you choose a k value? So we have taken here 5, yet we have taken 7. So how are you going to choose the k value? So let's see some suggestion for how the k value can be selected. So always prefer odd values. Okay. So what happens is that if there is a tie with even, there is a chances that if you take odd values, there won't be a tie. Okay. Prefer odd values as there is a chances of tying in even. So if still when you take odd values and it tie occurs, let's say you are dealing with a multi-class classification, and you see that two classes have got the equal majority. Okay, so in that case, increase or decrease the value of k. Okay, then only you can get the result. Okay, k should not be too small. Okay, k should not be too small. Usually, what happens is that k value is always considered to be square root of n. Thumb rule is takes k value to be square root of n, where n denotes the total number of data points. So let's say we have 125 data points. Okay, so k value should be square root of the total number of data points, that is k to 25. So 5. 5 is the optimal value of k over here. Similarly, if you have 416, so you can go with square root of 16 4. But k can vary also depending on the kind of classes you are dealing with. And also, your k value should not be too small, that you need to understand. So then further one can try different values of k and then observe the evaluation matrix. So you can also what also you can do is that what you just increase or decrease the values of k, okay, and just apply it on an evaluation matrix and see at what k value you are getting a highest accuracy of your model or highest precision and recall score as well. Okay, so you can use that method. So you can see the classification report and based on what value of k you are getting highest value for precision, accuracy, and depth of score. Based on that, you can decide, okay, you can go with this k value, or this is the only way you can do trial and error method. So observe the evaluation matrix and decide upon the best value of k. So how is the distance measured? Okay, so let's see how is the distance measured. Okay, so since KNN model classify the points based on, so before moving to this, so let me consider lazy learning. So KNN is also known as lazy learning. So why it is called lazy learner is at the time of training, it memorizes all the data points that are there. Okay, so it memorizes all data points, and finding the nearest neighbor is only done during the prediction time. Okay, let's say you have passed this training, so your model is going to memorize all the data points, and when and finding the nearest stable neighbor is done at the prediction, because let's say there is an unknown quantity over here and you want to predict which class it belongs. Okay, then what it will do is that it will memorize all the data points, and the prediction is done during the evaluation time. Okay, so finding the nearest neighbor is done during the prediction time or evaluation time. Hence, it is called lazy learning, because minimum training is required because it memorizes all data points. But during prediction time, it will take more time. So it's an expensive learning if you consider like that. So let me tell you this. So KNN is a lazy learning model. Almost all the models get trained during the training on the training data set. But KNN does not get trained in the training data set when we use KNN.fit. So KNN.fit is used to train the model, you might think, but what it actually does is that when you pass the data set, this model memorizes all the data points. Okay, it does not understand or tries to learn or underlying trend. Okay, it just doesn't understand anything or try to build any underlying trend. It just memorizes all the data points from the data set you have passed. Now, when we ask the model to predict the some value, so you want to predict to which class that value belongs, then it takes a lot of time for computation, because it is actually will have to recall all the points. Okay, so it actually have to remember all the points and work around them, and so that it can help predict the correct value. So what happens is that it has already memorized these points, and next you are telling that this point lies for here. So it memorizes. So whatever points that has memorized, what it will do, it will take some time. So it will recall all the points where it is present. So it will recall all the points where it is present, and during the evaluation time or the prediction time, it is tries to find the correct class for your unknown quantity. Okay. Hence, there are where most of the models take time during training. This model does not take time during training, because this model takes time during testing. During predicting. Okay, prediction is the part where this k nearest neighbors takes a lot of time, because it has already memorized the data points, and tries to recall whenever an unknown quantity, or whenever you're trying to find the unknown quantities class, it always tries to remember for each and every unknown quantity, and based on that only it is going to tell you, is it to which class it is based, or to which class it belongs to. Hence, where most of the models take most time during training, this KNN model does not take more time during training. Most of the models take no time in prediction, but KNN takes a lot of time for the prediction stage. Okay, because this is a lazy learner, which is based on a method of memorizing and recalling, and based on recalling and then finding the distance of data points from the unknown quantity, and then it has to do the majority of classes to which it belongs, And then based on the majority of classes, it will tell, so your neighbor or the unknown quantity is belong to this. So usually when you are in a locality and you want to ask, let's say you want to ask the behavior of a person, okay? So you will say you will have some 10, 50, like 20 houses, let's say near your neighbor or neighboring. So you have 20 houses, but your actual behavior will be known by the nearest neighbors. Okay, they will follow you, they will see you, right? So based on that, you can predict based on those. You can predict the behavior of yourself. Okay, so if you want to see the behavior of yourself, you can check the behaviors of the neighboring classes, neighbors that are present, and it can predict the neighbor behavior of your class. It is like that kind of logarithm where it is called k nearest neighbors for that sense. Okay, the nearest neighbors we will consider. Okay, so next, what we can do is that, so important points. So before moving to important points, now let's come to how is distance measured. Okay, so distance measurement can be done using Euclidean distance. Okay? Euclidean distance. So since KNN module classifies the data points based on proximity or distance, it is important to understand the different ways we calculate the distance. Okay? So we have Euclidean distance. Euclidean distance is nothing but from here to here. You want to calculate the distance. The distance from A to B will consider, B to C will consider, and then A to C is square root of AC B square plus BC. This is like a Pythagorean theorem kind of thing. Okay? Then we can find the distance using Manhattan. So let's consider a city block. Okay, so from A to B, the distance if you want to consider, you can go from here till here, or you can go from here, and reach here, or you can go from here and take a left and reach here. So these are the various ways you can come to come from B to A. So calculate the distance from B to A. So these are the various measures. With it, so what happens is that, so let me tell you Euclidean distance again. So by default, a nearest neighbor uses Euclidean distance. Minkowski with power p is equal to 2. Okay, so you don't have to worry about this power p is equal to. Just understand KNN uses Euclidean distance. That is like a distance between AC is distance from A square root of distance from AB plus square root plus BC. Okay, so Manhattan distance. So Manhattan distance, I have already told you. So it's like a block, city block. So it is a sum of horizontal and vertical absolute distances. Sum of horizontal and vertical. So from block C to G, if you want. So we'll go from here to block C to I. This is vertical distance, and this block I to G, this is horizontal distance. If you want to go from block A to I will go from block A to D, and I will block A to G, and I can go from block G to I. So we have for vertical as well as horizontal distance. Manhattan distance is summation of square x2 minus x1 plus y2 minus y1. Okay. So in general, it is written as summation of ai minus bi. So we have used the property of cosine similarity over here. So let's take this. So imagine you are taking a taxi from block I to block A. Okay, from here to here. The part which they think a taxi takes, and the overall distance is calculated by sum of all the vertical and horizontal values. Okay, so this is all about Manhattan and Euclidean distance. So KNN uses distance matrix where you can use Euclidean distance, Manhattan distance. Euclidean distance is nothing but distance between AC is equal to square root of AB square plus BC square. Whereas Manhattan distance is the sum of horizontal and vertical distances we consider. So this is all about KNN model, and some important points you need to note out is, so you need to understand, since it is a based on distance based model, feature scaling is a must for it. Okay, so you have to do the feature scaling because so you can scale the values between a range of between zero around zero between -3 and 3 using Z score. Okay, it can be any value between that after scaling. Okay, so scaling can be done using scalar, standard scalar, or you can do go with min max, depends. Okay, so, and also besides logistic regression, the rest of the models that we have discussed till now is multi-class classification. Okay, but logistic regression, we take a regressor line, and above that regressor line is considered to be class A, and below that is class B. So we have only two classes over there. So output class, two categories. So here we have multi-class classification. Okay, so this also KNN is also a multi-class classification, but only logistic regression is not a multi-class classification. So you have to remember this. So now let's move to the finding the value of k. So I've already told you the way how to find the value of k. Usually k should be odd toward the class sorting. So what happens is that when you have k taken as even and you see that there is a tie. So for tie breaking of tie, you might have to consider k value to be odd. Okay. Take help from accuracy or precision or equal and then decide the range of k. Okay, so we can take evaluation matrix, and based on that accuracy, precision and equal, you can decide the value of k or range of k. So optimum k value we usually say is it should be root of n, but it depends. You have to go with the evaluation matrix and avoid very small value of k. Okay, so here, let's say here the accuracy for this K point is around high, and it almost stabilizes after that. So this is the optimal value of K. So hope you understood this session. Thank you. Thank you for attending the session. I will be covering the coding part in the next session.